Welcome to the Kelly Paper Online Training System. My name is Ed Sterling. This series of 6 modules focuses on disaster preparedness and specifically looks at the most likely natural disasters to affect Kelly Paper. The natural disaster that has the potential to have the greatest impact across the organization by far is earthquake. Most of this series will be dedicated to earthquake preparation, but we will also discuss fires. Throughout this series, I will provide a significant amount of historical information which is widely available online. The guidance that is provided here is based on materials taken from the U.S. Geological Survey official website, Shakeout, Red Cross, SoCalGas, and other legitimate sources. On January 12, 2010, a 7.0 earthquake occurred in Haiti in the Caribbean Sea, resulting in approximately 230,000 deaths, 300,000 injuries, and 1 million people being homeless. Then, on February 27, 2010, an 8.8 earthquake struck Chile, resulting in a tsunami warning going out across the entire Pacific Basin, over 700 deaths, and over 1 million people being displaced. But a fact that did not receive as much news coverage is that during January and February of 2010, there were 12 other earthquakes of 6.0 magnitude or greater occurring on Earth. And with the exception of Haiti, all of them occurred in the so-called Ring of Fire shown here. As a Kelly Paper employee, you will notice that our operating area in the western United States is part of this designated area. For this reason, it makes sense at the very least to have some fundamental knowledge about earthquakes, what to expect, how to prepare, and how to stay safe. So this 6-module series is organized as follows. Module number 1, Earthquake Country. We'll take a look at earthquake history in Southern California, the probabilities of future earthquakes, and take a look at some technical basics about magnitude, intensity, and etc. We will also look at the Great California Shakeout, which is an organized scenario developed by governmental agencies designed to prepare Californians for a large seismic event. Modules 2 and 3 are about preparedness. In Module 2, we will cover the goals of this training series. We will look at the potential effects to the infrastructure and to transportation. We'll also look at how a significant earthquake could affect Kelly Paper. We will then consider each element of our interlocking safety approach, covering cultural considerations of preparedness, our physical surroundings, and the systems that we have in place to help us before, during, and after an earthquake. Module number 3 looks at disaster preparedness at home and recommends the establishment of an evacuation plan for your family, a gathering location, water, food, and supplies, utility considerations, and other considerations. Module number 4 focuses on the moment of an earthquake. There are similarities with how you should react if you are at home or at work, but each has its own unique considerations. So we'll look at what the experts recommend we do during and immediately after an earthquake. We'll also look at the so-called triangle of life, which you may have seen circulated on the internet. Module number 5 focuses on fire and some considerations and actions that are important. And module number 6 takes a deeper look at preparedness and contains some action items for you to consider. So let's get started. This is module number 1. Earthquake Country. As shown in the earlier slide of the Ring of Fire, California is in a significant earthquake zone. This slide shows that earthquakes are not rare events. Including Alaska and Hawaii, 882 earthquakes took place in the United States in this one day, March 18, 2010. The vast majority of them were so small that they weren't even felt. But seismic events are certainly not rare. The Earth is moving all the time. California's 35 million people live among some of the most active earthquake faults in the United States. According to the Uniform California Earthquake Rupture Forecast, The probability of a magnitude 6.7 earthquake occurring in California within the next 30 years is greater than 99%, a near certainty. The probability of a magnitude 7.0 is 94%, also a near certainty. And the probability of a 7.5 is 46%, and the probability of an 8 is an unlikely, but possible, 4%. Additional statistics show that the probabilities are higher in the southern half of the state versus the northern half. And the most dangerous fault is the southern part of the San Andreas, right in the backyard of most of Kelly Paper's stores. There's a 59% probability of a magnitude 6.7 or greater along this section of the fault within the next 30 years. On July 29, 2008, many Kelly Paper employees experienced the Chino Hills earthquake. This was a fairly minor earthquake in the great scheme of things, measuring in at 5.4, but it was still felt as far south as San Diego and Tijuana, and was also felt in Las Vegas. One way to look at this is that it was an inconvenience quake. Thankfully, there were 0 deaths and only minor structural damage. The volume of telephone activity occurring immediately after the quake, however, overloaded the phone system, resulting in disrupted telephone service. We had a ruptured sprinkler pipe in the Kelly Paper warehouse, and there were some electrical outages in the area. There was a bit of damage from items falling off of store shelves, and there were definitely many frayed nerves. This map and its colors provide a visual representation of the earthquake at Chino Hills. As you can see from the legend at the bottom, blue represents light shaking, and green and yellow represent strong shaking. This map shows very little, if any, orange or red, which represents severe or extreme shaking. So again, Chino Hills at 5.4 was pretty minor. But at Kelly Paper, we learned a lot from this little quake. Despite the fact that we regularly conduct evacuation drills, and people have been told in the past to remain calm in an emergency or in an earthquake, for some, the opposite happened. Many people did not know what to do during the quake or what to do immediately after. At the corporate office, we literally had people run for the exit, we had people try to crowd into a closet, and some looked around to see what everyone else was doing, while some remained calm. This sent a clear message to us that our employees are not sufficiently prepared. They just did not know what to do. Beyond that, from a business perspective, we also were not prepared. We were not prepared to treat injuries, or to effectively communicate with each other, or to help someone who was trapped or take control of the situation. We had some work to do. Taking a little deeper historical look at earthquakes in Southern California, on June 5, 1990, there was a magnitude 5.7 in the area of Claremont and Pomona, $12.7 million in damage, and again some frayed nerves. This one violently shook the old Kelly Paper Montclair store and moved a fully loaded row of shelving weighing thousands of pounds from its original position. The largest earthquake to hit Southern California in recent memory was the Northridge quake on January 17, 1994. Centered just north of Los Angeles, a magnitude 6.7 occurred in a major metropolitan area and caused $10 billion in damage, 57 deaths, and 1,500 serious injuries. It is important to note, and we will elaborate more on this in Module 4 of this series, that most injuries were from falls caused by people trying to get out of their homes. Most injuries were not caused by structures falling on them. This is very important because what you choose to do at the moment of a quake and immediately after can have a significant impact on whether you avoid or sustain an injury or worse. And quite literally, what region of the world you are in, as evidenced by the fatality differences between Haiti and Chile, discussed back at slide number 2, will have a significant effect on the survivability of the quake. Taking a look at the shake map for Northridge shows a much more significant event than Chino Hills. Recall that there was no orange or red coloring representing severe or violent shaking in the Chino Hills example. Northridge was much more significant. The infrastructure effects were dramatically more severe, as shown in these next two slides. This is a freeway overpass support. And this is a gas leak and a water leak in Simi Valley. And Kelly Paper certainly did not escape the 1994 Northridge earthquake unscathed. These next several slides show the damage that occurred to the Kelly Paper Chatsworth store. Take a look at the left side of this photo. A chemical spill was narrowly averted. This could easily have become a fire issue, which would have dramatically escalated the damage from this quake. So now that it's pretty clear that earthquakes cause tremendous damage and disruption, let's take a look at what actually causes an earthquake. To put it simply, it's a sudden slip of a fault, which is a crack in the earth. The slip is much like snapping your fingers. When you snap your fingers, you apply pressure between two fingers and exert a sideways motion. The combination of the pressure and the motion creates a snap, which is sound, vibration, and a release of energy. In essence, this is what is happening when a fault slips: tremendous release of energy, extreme vibration, and a lot of noise. Magnitude is often misunderstood or misinterpreted. Earthquakes are described as a magnitude 6.0, 7.2, etc. In simple terms, magnitude measures the energy released at the source of the earthquake. The bigger the number, the bigger the quake. By contrast, the intensity of an earthquake is a measure of how violent the shaking of the earthquake is. What a person experiences in terms of shaking if they are standing 5 miles from the epicenter of an earthquake may be very different from what someone experiences standing the exact same distance away, but on the other side of the epicenter. The type of ground the person is standing on, and multiple geologic features under the surface of the ground in the surrounding area affect the shaking and the intensity that is experienced on the surface. Bear with me as we get a little technical on this slide. First, the Richter scale compares earthquake size using a logarithm of the amplitude of waves recorded by seismographs. Because of the logarithmic basis of the scale, each whole number in increase in magnitude represents a tenfold increase in the measured amplitude. As an estimate of energy, each whole number step in the magnitude scale corresponds to the release of about 31 times more energy. This explains why a magnitude 6.5, for example, can have a dramatically greater intensity and cause significantly more damage than a magnitude 6.0. It also explains why the differences in earthquake size using a magnitude comparison are not universally understood. As a more simplistic comparison, this chart gives us some sense of the relative strength of an earthquake as it is likely to affect structures in the United States. From 5.4 to 6.0, we can expect some localized damage. Any earthquake in the 6 range is pretty destructive. Any earthquake in the 7 range is very destructive. 8 or above is tremendously destructive. Here's a little earthquake trivia. The largest recorded earthquake in California was a 7.9 back in the 1800s. The largest recorded earthquake in the United States was at Prince William Sound in Alaska, 9.2 in 1964, also known as the Great Alaska Earthquake. And the largest earthquake in history was in Chile back in 1960, coming in at 9.5. Can California fall into the ocean? No, that's absolutely impossible. That's not how earthquakes work. But southwestern California is moving slowly 2 inches per year, which is the rate your fingernails grow, towards Alaska. At that rate, 15 million years from now, Los Angeles and San Francisco will be next-door neighbors. A little more earthquake trivia: there is no such thing as earthquake weather. The San Andreas is a system of faults or cracks in the earth 800 miles long. And an earthquake fault is not going to swallow you. Gaping faults do not exist. The ground moves parallel to a fault during an earthquake, not away from it. The earthquake scenarios in the movies can be far removed from how earthquakes actually behave. Now I'd like to introduce you to the shakeout scenario. It is the product of an interdisciplinary collaboration of over 300 scientists, engineers, and other experts from several agencies, including the U.S. Geological Survey, the California Geological Survey, Southern California Earthquake Center, California Office of Emergency Services, and Seismic Safety Commission. The shakeout scenario is based on a magnitude 7.8 earthquake occurring on the southern San Andreas Fault. That is approximately 5,000 times larger than the magnitude 5.4 Chino Hills earthquake that shook Southern California on July 29, 2008. Think about that, 5,000 times larger. It's not a matter of if an earthquake of this size will happen, but when. The shaking will last for nearly 2 minutes, which is in contrast to Northridge, which lasted only 10 to 20 seconds. The animation on this slide will move faster than real time, as you will see from the second counter at the bottom left. This is an illustration of the shockwave travel and the intensity under the shakeout scenario, with the epicenter being on the east side of the Salton Sea. Such an earthquake will cause unprecedented damage to Southern California, greatly dwarfing the massive damage that occurred in Northridge's 6.7 magnitude earthquake in 1994. The strongest shaking will occur near the fault, in the projected earthquake, the Coachella Valley, Inland Empire, and Antelope Valley. Pockets of strong shaking will form away from the fault where sediments trap the waves. In the projected earthquake, it would occur in the San Gabriel Valley and in East Los Angeles. 10 million people will be exposed to heavy shaking. Strong shaking will occur in downtown Los Angeles for 55 seconds, which is much longer than occurred during the Northridge earthquake. All unreinforced masonry buildings within 15 miles of the San Andreas Fault are completely destroyed. Collapse of hundreds of brick buildings, thousands of older commercial and industrial concrete buildings, many wood frame buildings, and even a few high-rise steel buildings. And over 600,000 buildings will suffer some damage. This earthquake could cause over 1,800 deaths, 50,000 injuries, $200 billion in damage and other losses, thousands of people homeless or jobless, and severe, long-lasting disruption. The incident would have not just local but regional implications and is a dramatic call to action for preparedness. Fire doubles the fatalities and economic losses. It is thought that more damage was done by the resulting fire after the 1906 San Francisco earthquake than by the earthquake itself. 1,600 fires warranting 911 calls, and some fires merge into conflagrations that burn hundreds of city blocks. Nearly two-thirds of the hospital beds are non-functional in Los Angeles, Orange, Riverside, and San Bernardino counties. Meanwhile, 50,000 people will seek treatment at emergency rooms. Many bridges are non-functional, resulting in highways being unpassable. The largest long-term economic disruption comes from damage to the water distribution system. Damage to this system will be so extensive that some areas will have to replace the whole system, and some buildings will be without water for as long as 6 months. The direct and indirect business interruption costs attributed to the lack of water will be around $50 billion. In the next module, we'll look at the goals of this training program and look at disaster preparedness specifically at Kelly Paper. So this concludes module number 1 on disaster preparedness. Please complete the quiz on your workbook, and remember, at Kelly Paper, safety is always first. Goodbye for now.